A single invention made cities explode into the sky. The Bessemer process changed everything. Before 1855, steel was a luxury material, incredibly expensive and hard to make. Iron was common, but it was brittle. It cracked under stress and rusted away fast. Imagine the challenge of building big things. Bridges that spanned vast rivers, tall buildings reaching for the clouds, railroads crisscrossing continents. All of it depended on a stronger, more reliable metal. Iron just would not cut it. Henry Bessemer, a British engineer, faced this problem head on. He needed a stronger metal for cannons. His initial attempts were not great, but then a fluke observation led to something amazing. He noticed some iron stayed pure after being exposed to air. This gave him an idea. What if blowing air through molten pig iron could remove the impurities? That was the core of it. Others, like William Kelly in America, had a similar thought independently a few years earlier in 1851, but Bessemer got the patent first in 1855. His patent was a game changer. The process itself was remarkably simple. First, pig iron, a raw form of iron with high carbon content, was melted down. It needed to be extremely hot, around 2,800 degrees Fahrenheit. Then this molten iron was poured into a large egg-shaped vessel called a Bessemer converter. This converter, usually 30 feet tall, weighed perhaps 15 tons. It rotated on an axis. The real magic happened next. A powerful blast of air was forced through the molten metal from holes in the bottom. This air reacted with the impurities inside the iron, especially carbon and silicon. These elements would oxidize, they would burn away. This burning generated even more heat. The temperature inside the converter would actually rise during the process. It was a spectacular sight. Flames and sparks would shoot out of the converter's mouth. The whole process took only about 10 to 20 minutes. This was incredibly fast compared to previous methods, which could take days. Within minutes, a batch of crude iron was transformed into liquid steel. The early Bessemer steel had some issues, though. It was often too brittle because of leftover sulfur or phosphorus impurities. These elements did not burn away with the air blast. Robert Forrester Mouchette came up with a solution. He added a precise amount of spegulizin. Spegulizin is a type of iron rich in manganese and carbon. This addition helped remove the remaining oxygen and also added back a controlled amount of carbon. It made the steel much stronger and more workable. Without Mouchette's contribution, the Bessemer process might not have succeeded. The impact was immediate and profound. Steel production costs plummeted. Before Bessemer, steel cost around $100 per ton. After Bessemer, the cost dropped to roughly $12 per ton by 1870. This massive price reduction meant steel was no longer a luxury. It became an everyday material. Suddenly, engineers could dream bigger. Railroads were one of the first beneficiaries. Steel rails lasted 10 times longer than iron rails. Tracks could handle heavier, faster trains. This sped up transportation and industrial growth across continents. Cities began to change dramatically. Skyscrapers became possible because of steel frames. The home insurance building in Chicago, built in 1885, is often cited as the first skyscraper. It was 10 stories tall. That building used steel. Stronger, lighter bridges could span wider rivers. The Brooklyn Bridge, completed in 1883, was a marvel of engineering, using miles of steel wire for its cables. Its towers stood 276 feet high. Ships were built from steel. They were faster, larger, and more durable than their iron counterparts. Tools, machinery, weapons, and countless other products were suddenly made from this stronger, more reliable metal. The steel industry exploded. From just a few thousand tons of steel produced annually in the 1850s, output soared to millions of tons by the turn of the century. By 1900, the United States alone produced over 10 million tons of Bessemer steel each year. This one process fueled the Second Industrial Revolution. It built the modern world we recognize today. It created an enormous demand for iron ore and coal. Mining operations grew. New towns and cities emerged around steel mills. Thousands of jobs were created. It was an era of unprecedented industrial expansion. The Bessemer process was not perfect. It could only use certain types of iron ore, usually those low in phosphorus. This limited where steel mills could be built. The impurities, like phosphorus, needed other methods to be removed. Eventually, other steelmaking processes, like the open hearth process, which could handle a wider variety of iron ores and scrap steel, became more dominant. The open hearth process, developed by Carl Wilhelm Siemens and Pierre-Emile Martin, starting in the 1860s, slowly replaced Bessemer converters. It was slower but more controllable. It also had the advantage of using scrap steel. Later, the basic oxygen process, starting in the 1950s, largely superseded both Bessemer and open hearth furnaces. But for several decades, the Bessemer process reigned supreme. It was a technological marvel that reshaped civilization in an incredibly short time. It truly ushered in the age of steel.